Hello and welcome back. Today we're going to be talking about section 3.6, quadratic functions in general form. So let's just review over a few things. A quadratic function is a function of degree 2, meaning that the highest exponent in that is 2. The graph of a quadratic function is a parabola. It's a U-shaped graph. Now the general form of a quadratic function is written as f of x equals ax squared plus bx plus c, where a, b, and c are real numbers and a cannot be 0. Now the y-intercept is always going to be this c value here. And so we say that the y-intercept is 0, comma c. Remember when we're finding y-intercepts, x is 0, and then we solve for the other value. And the vertex is at h, comma k. However, you'll notice in this general form, we don't have an h, comma k, so we can't easily pick out where that vertex is at. So we actually need to have a vertex formula to help us find that. H is negative b over 2a, so that's our x-coordinate. And then once we find that, we will plug that back into our equation in place of x to figure out what that f of x value is. All right, now just a little bit of review from before. Back in 3.3, we talked about vertex form being f of x equals a times x minus h quantity squared plus k, where h and k is the vertex. So in this one we can see that we have the vertex easily found, thus it's called the vertex form. And then in 3.4 we talked about intercept form, which looks like f of x equals a times x minus p times x minus q, where p and q are the x-intercepts of the graph. And we can find the vertex because its x value will be halfway in between the two intercepts, the two x-intercepts that we found. All of those are quadratic functions. There's just a lot of different forms for them to be in. So depending on which form our quadratic functions are written in is going to help us figure out which way is going to be the best way to find the different parts of the parabola so we can graph it. All right, let's talk a little bit about the parts of the quadratic equation in general form. Like I said before, our general form is f of x equals ax squared plus bx plus c. And so we need to figure out how do the a, b, and c values, how do they change the graph? So the a value is pretty similar to what we talked about before in vertex form and in intercept form. It controls the parabola's opening direction. Is it opening up? Is it opening down? And it also is helping us figure out if it's becoming more narrow or if it's more wide. So that is the same thing. The a value in this does the same thing that it did before. Now the b value is a little bit different, but it changes how steep the parabola is at the y-intercept. So if b is positive, then the slope of the parabola at the y-intercept is increasing. If b is negative, then the slope of the parabola at the y-intercept is decreasing. Right? So it's just about the increasing or decreasing at that y-intercept. And then our c value, we talked about a little bit about before, but it is telling us our y-intercept. It's telling us where the graph intersects that x-axis. And so, like I said, in order to find the vertex of the parabola, we might need to use this formula. So make sure you have this memorized. So for our x coordinate, it's going to be negative b over 2a. And once we find that, then we can substitute that x value back in place of our x's to figure out what f of x or what y is. And that's going to give us that turnaround point of a parabola, which is a really important part of the parabola. Now also remember from before we talked about the maximum and minimum. So the vertex is lowest at the minimum point of the graph. And that means that you'd have a graph that opens upward. And then that lowest point is the vertex, so that's the minimum. However, if we have an upside down parabola, then our vertex is going to be a maximum point on the parabola. All right, let's take a look at this first problem and find the vertex of the quadratic function f of x equals 2x squared minus 8x plus 7. Rewrite the quadratic function in vertex form. So it's telling us find the vertex first, and then we're going to use that to change our quadratic function into vertex form. So let's first identify these. So remember, our a value is in front of our x squared term. So we're going to say a equals 2. B is in front of our x term. And so we're going to say b equals negative 8. Make sure whatever sign is with it, you put in that value, right? It comes along with it. Don't leave it behind. All right, and then our c value is going to be that 7, that constant term. All right, so now let's go ahead and find the vertex using the vertex formula. We said that the vertex formula, we're going to have x equals negative b over 2a. Or we'll have x equals, we've got a negative 8 here, so we need to be careful because we're doing the opposite of negative 8. All over 2 times a, which is 2. All right, let's keep simplifying this so we can figure out what our x-coordinate of our vertex is. So we'll have a positive 8 on the top and a positive 4 on the bottom. So that means x equals 2 after I divide those. So that is my x coordinate of my vertex. Okay, so I'm going to write that up here. So positive 2. Now, I'm not done yet. I need to find the y value as well. And remember, y is the same thing as that f of x. So to find our y value, let's take our equation and we're going to substitute that 2 in place of x. Okay, and then when I do that, let's see what we come up with here. So 2 squared is 4, and then 4 times 2 is 8, minus 8 times 2, which is 16, and then plus 7. So 8 minus 16 is negative 8, plus 7 is going to give us a negative 1. So that means our vertex is going to be at the point 2, negative 1. All right, so we finished the part B. Now on part C, we're going to use that answer to be able to write this in vertex form. So let's remind ourselves what vertex form looks like again. So it's in the form of f of x equals a, parentheses, x minus h, quantity squared, plus k. So we need to fill in our values here for a, h, and k. f of x equals, in place of our a, we'll put 2 times x minus, well, let's see, our h value is 2, so minus 2, all squared, and then plus k, this is going to be our k, remember this is our hk, and so -1, so minus 1. So there we have it. That is the equation, but just now in a different form. So these two functions, if you were to graph both of them, you would see that it is the same exact graph. They're just written in a different form. I hope that was helpful in being able to get started on 3.6, where we're talking about general form of a quadratic equation.